Hi everyone and welcome back. Today we are diving into a topic that's absolutely essential for every developer and especially important if you are preparing for your Cisco DevNet Associate exam, which is the software version control. Now, if you have ever written code or collaborated on a project with others, you have probably run into the same challenge. For example, how do you keep track of changes? How do you know who changed what and when? And most importantly, how do you make sure that you don't lose your work along the way? That's exactly where version control systems comes in. They act like a safety net for your code. So tracking every change and helping team collaborate. And of course, giving you the confidence to experiment without fear of breaking things. So in this video, we are going to unpack everything you need to know about version control and how it fits into modern software development. So we will start by answering the question, what exactly is software version control? And I will show you how it keeps your projects organized and your code history safe. And we will also talk about why version control really matters. And then after that, we will move into one of Git's most powerful features, which are branching and merging. For example, how developers can work independently on different features without stepping on each other's toes. After that, we will take a closer look at understanding Git itself, how it works under the hood, and why it's become the industry standard for version control. We will also walk through the Git File Lifecycle, where you will see exactly what happens to your files as they move from being untracked to modified to committed, and how Git keeps everything in sync. And then finally, we will wrap up with a look at local versus remote repositories, where your code actually lives, and how developers collaborate across teams. So by the end of this video, you will not only understand how version control works, you will also be able to see why it is such an important skill for developers and network automation engineers alike. So again, stick around. This is one of those topics that will change the way you write and manage and share your code forever. Alright, let's start with the basics. What exactly is software version control? So if you have ever worked on a document, let's say saved multiple versions like final.txt or final_final.txt or final for real this time.txt as you see on the screen, then you already get the idea behind version control. But in software development, things get a lot more complicated, and that's where version control systems come in. So software version control, or SVC for short, is a system that tracks every single change made to your code. It saves all the versions, past and present, and lets you go back in time whenever you need to. So I want you to think of it as a time machine for your source code. You can see who made a change, what they've changed, and when they've changed it. And the beauty of it is that it allows multiple developers to work on the same project at the same time without overwriting each other's work. So let's imagine you are a developer named Alex working on a new web app for your team. You have just finished writing some new code and everything looks perfect on your laptop. But here is the challenge. You are not working alone. Two other developers, these are Sam and Taylor, are also working on the same project and possibly on the same files. Now, imagine all three of you are editing the same code at the same time. Without any coordination, one person's changes could overwrite another. It's like three people writing on the same document without knowing who's doing what, which is total chaos, right? That's exactly where software version control steps in. Okay, so take a look at this diagram. On the left-hand side, we have got Alex, our developer, which is working on their code. When Alex is happy with their changes, instead of saving them locally and hoping nothing breaks, they send those changes to a version control system. That is the cylinder in the middle. So inside that system, something magical happens. Every single change is tracked. The system saves a new version, say version 1 and version 2 and version 3, so on and so forth. And for each version, it records who made the change, when it was made, and what exactly was changed. So, in other words, it's keeping a full history of your project. Now, look at the two developers on the right hand side, that's Sam and Taylor. They can both pull the latest version of the code from the version control system and they can work on their parts independently. And then later they can push their changes back in. So the system makes sure everyone stays in sync. No one's work gets lost or accidentally overwritten. So notice those icons at the bottom? That little clock represents time travel because with version control, you can always roll back to a previous version if something breaks or doesn't work out. And that shield that you see on the screen, that's protection. So your code is safe and every version is stored securely in the system as well. All right, now that we know what software version control is, let's talk about why it actually matters. Because at first glance, it might just look like another developer tool, but honestly, it's so much more than that. So software version control is basically your safety net as a developer. It keeps track of every single change made to your source code, like a detailed journal that remembers everything you have ever done. Not to mention, it saves all your past versions, so if something goes wrong or you make a mistake, you can easily roll back and restore a previous working state. No panic, no stress. It also makes teamwork so much smoother, so multiple developers can work on the same project at the same time. And of course, every change is recorded, who made it, what they've changed, and when it happened, which means total transparency and accountability. And finally, version control protects your code from being lost or accidentally overwritten. So your work is safe, backed up, and always recoverable. So whether you're coding solo or with a big team, version control gives you peace of mind, knowing your project's history and your progress are always protected. Alright, now let's talk about one of the coolest parts of version control, which are branching and merging. So if you have ever wondered how multiple developers can work on different features at the same time without breaking each other's code, well, this is how it happens. So let's start with branching. So imagine your main code base, the version everyone uses as the main road. Now, what if you want to build a new feature or try out an idea, but you don't want to mess up that main road? So this is where you create a branch. So a branch is like building a side road that splits off from the main one. You can drive down that road, make changes, experiment if you want, and test new ideas without affecting what's happening on that main road. And here is the beauty of it. You can have multiple branches. Each one represents an independent workflow. Maybe one branch is for a new login feature, another one is for bug fixes, and another one is for testing out a new design. So everyone can work in parallel, safely and independently. Now, what about merging? So once your work on a branch is done and tested, you will want to bring those changes back into the main project. That process is called merging. It's like reconnecting your side road back to the main highway. But now your new improvements become part of the main flow. If the main code changed while you were working, Git will help you merge those updates together. Sometimes it's seamless, and sometimes you might need to resolve a few merge conflicts, which just means Git found differences that need a human decision. But once everything's merged, your new feature becomes part of the main code base, and the whole team benefits from your work. Now, let's take a closer look at Git, because Git is the tool that makes version control come alive in the real world. So if you have ever worked on code and wished you would go back in time, maybe undo a change or restore an older version or see who touched what, Git gives you all of that and more. Now, What makes Git so special is that it's distributed. That means every developer has a full copy of the project, not just the latest files, but the entire history of every change ever made. You don't need to be connected to a central server to work. You can commit, or you can branch, or even review history completely offline. Later, when you are ready, you can then sync those changes with the rest of your team. So let's break down what actually happens when you use Git. When you first clone a repository, you are basically making a copy of the project on your machine, files, history, and everything. From there, you will spend most of your time in what's called the working directory. This is your local workspace where you edit files, add new ones, or maybe delete a few. When you make changes, Git doesn't automatically assume you want to save them in history. Instead, you decide which changes you want to track by using the command git add and then the name of the file. That's how you move your changes into what's called the staging area. Think of the staging area like a waiting room, so your changes sit there until you are ready to log them in. Maybe you have been editing several files, but you only want to commit a few of them. The staging area lets you pick exactly what to include. Once you are happy with what's staged, you then run git commit. And that's when Git takes a snapshot of your work, a permanent versioned record stored into your local repository. Each commit comes with a message you write yourself and includes details like who made the change and when. Now, what's cool is that each of these commits link back to the one before it, forming a chain that tells the story of your entire project. You can jump back to any points in time and compare versions, or even create new branches that explore different directions of your code without touching the main version. And that's where Git really shines in how it handles collaboration. Because it's distributed, you and your teammates can all work on different parts of the project at the same time. So you can create your own branch to build a new feature, test it, and once it's ready, you can then merge it back into the main branch. So when you are done working locally, you can then push your commits to a remote repository like GitLab or GitHub. That's where everyone's changes come together. Others can then pull your updates, review your work, or keep everything in sync. If two people happen to edit the same file, Git will let you know there is a major conflict. It's just saying, hey, I can't tell which version you want me to keep. Then you step in, fix it manually, and then move on. So the first impression that you might have is that Git can feel like a lot of commands, but once you understand the flow from editing in the working directory to staging, committing, and syncing with the remote, for example, it all starts to make sense. So please remember that Git gives you control, it gives you visibility, and it gives your team the freedom to experiment without fear of losing progress. Now that we have a foundational understanding of what Git is, let's look at how it works. So the core of Git's operation can be understood through what we call the Git File Lifecycle. So I want you to imagine you're working on a project and you create a new file. It's fresh on your hard drive. You can open it, type into it, save it. But Git hasn't been asked to pay attention yet. In Git's eyes, this little file is untracked. It's visible to the system, but it's not part of the project's history. At this point, nothing you do with that file affects the recorded timeline of the repo. It's just floating in your working folder. Now you have a decision to make. Maybe the file is useful and should be part of the project, or maybe it was a quick scratch file you don't want to keep. So if you remove it, delete it from the working folder, then the working directory returns to a state that matches the repository. Nothing is pending and everything is as recorded. So effectively, you are back to unmodified. The file never entered Git's story. Alternatively, if you choose to add it to the project, you act intentionally. You tell Git, I want this in the project. So after you add it and follow through by committing, the file becomes tracked. And with no further changes, it sits in the unmodified state. It's now part of the recorded project and matches the latest snapshot. In both paths, either deleting the file or incorporating it and committing, the common result is a calm working tree where Git sees no outstanding editing, which is unmodified. So sometime later, you open the file and change a line. Maybe you correct a typo or add a new sentence. The moment you save that edit, Git instantly notices that the file no longer matches the last committed snapshot. So the file's state flips to modified. This is a transient in progress state. Git recognizes something changed, but you haven't told it to include that change in the next historical snapshot yet. This is a comfortable stage. You can keep editing, test locally, or even make more related changes across several files before packaging them up. When you are happy with the changes and you want to include them in the project's history, you then stage them. So staging is deliberate. It's you curating the next snapshot. You might stage everything or stage just a part of the file if you want to split unrelated edits into separate commits, for example. Once staged, the file status is staged. So I want you to think of it as placing your changes on a conveyor belt. They are queued up and ready to be committed, but they aren't permanent yet. So staging gives you the chance to craft tidy and meaningful commits, which is a top quality habit for collaboration and future debugging. Finally, you run git commit with a message that explains what you've changed and why. So Git takes the staged contents, packages them into an immutable snapshot, and stores that snapshot in the local history. Then the file's state returns to unmodified relative to the newly created commit because what you see in your working directory now matches the latest recorded version. The commit becomes part of the chain of history that you and your teammates can inspect or share or roll back if needed. So when you work with Git, understanding the difference between local and remote repositories helps make sense of how code collaboration actually happens. Both have the same capabilities at their core. They store versions of your files and track every change, but these serve different purposes depending on where your work lives and how it's shared. So let's start with the local repository. This is the copy that lives right on your computer. It's personal, self-contained, and designed for everyday development work. Whenever you run commands like git add or git commit or git branch, you are working strictly within your local environment. You can track files changes or roll back to earlier versions or maybe experiment with new ideas and create feature branches, all without being connected to the internet or any server. Git was designed to be distributed, which means every developer's local repository is a complete version of the project with its own full history. That's part of what makes Git so flexible. You can code and commit wherever you are, even offline. So when you commit, you are simply saving those changes into your local repository's database. Nothing leaves your computer yet. Now, the remote repository is a shared version of that same project that lives on a server, often hosted on a platform like GitHub or GitLab, for example, and the remote is where your local repository communicates with others. It's how teams exchange updates and keep everyone's work in sync. So when you are ready to share your changes, you use the git push command to send your commits from your local repository to the remote one. Likewise, if you want to bring in updates that teammates have made, you can use the git pull to download and merge their latest changes into your local copy. In essence, the remote repository acts as the central meeting point where everyone's progress comes together. So a common workflow looks like you clone a remote repository from GitHub to get your initial local copy, you make your changes and commit them locally. Then when things are tested and ready, you push your changes back to the remote so that the rest of your team can see and work with them. If someone else makes updates to the remote repository, you simply pull those changes down into your local copy, and this back and forth syncing, push and pull is what keeps everything aligned. So that's it for this video. I hope it was informative for you, and if you found it helpful, please don't forget to give it a thumbs up, and if you haven't already, please hit that subscribe button and turn notifications so you never miss our future tutorials and tech insights. If you have any questions or thoughts, feel free to drop a comment below, and to read more about this topic, be sure to check out my blog. You will find the link in the description below. And remember, consistency and hands-on practice are key to success, so stay curious, stay inspired, and until next time, peace.